trivial. I don't like this at all. Whether or not they are products, I should be able to just get the underlying type and underlying constant for each, and then I can combine them. Let me try that. So neither is a constant. Maybe. You have to combine the vectors. Let's just do an. Let me create a new constant. Means. Better make this a consecration then, right? No, the miss. So this thing E1 might have a vector, constant vector, so does E2. The rest vector is not constant, so yeah. That's all I need then. It's the non-constant part of the product or whatever it is. Let's call it the non-constant. Then I add the two constants If that is 0, then the rest is 0. The whole return thing is 0. If it's 1, I can ignore it. It means that I have to reconstruct that thing. But that should be the same for both. I can just return E1 argument 1. No, it depends on what E1 is. Yeah, I just have to give up on some mumble. I'm just going to return a new type, which is weird in itself. I mean, not a new type, but a new object. I can't do that. A lot of stuff doesn't even have a default constructor. Yeah, let's just make this a non-type then, so I can return it. So the type of the non-constant factor of argument 2 should be the same, which is a mouthful. We have to test it. Both are probably cons references. I think I lost the cons reference here. Maybe we should keep the cons reference. So let's get non-constant factor, return a cons reference, then I can test the type of that. The declaration type of the non-constant factor. So equal to the declaration factor of get non-constant factor of arg2. No, construct a constant factor here. 0, 0 is 1, and now I can just return this. Else it's neither 0 or 1, so now I have to return a product using the factor that is not 0 or 1, aka this one, together with the non-constant factor. Yep. Now you have to implement this one. So that is a struct having a template with some arguments, and it's named the get factor, derived from standard false type to begin with. And then we can construct a template, probably the same, I don't know, const expression bool. No, yes, no, wait, that's not what I want. No. It's not a bool. That would be for the value. Probably don't even need 20 minutes. I don't even need a false type, really. Don't know what I need. Maybe nothing. in the end, I'm going to need a using. It's definitely a template. What am I passing here? E1, yeah, that is a could be all kinds of things. Let's just call that an expression. So here too. And this is going to be a type. No, that's I don't know what it usually works. How does that usually work? Fuck me. Okay, sorry, I'm completely lost, so I'm just going to ask the meaning. See if it is as stupid as usual or not. I know about standard is same v. It returns a value. There are also two things. Can you give an example? Is integral. No possible implementation, yeah. Standard bool constant. It's an is integral. I don't see an is integral t. It says v. So it's full of shit. I'll ask it a simple question and it doesn't give me any good answer. I think this is one that might work. Also no underscore t. Oh, there it is. Remove reference t. Okay. Oh. So that is indeed a using, and then yeah, you need a type name. Okay, but for the rest. So that looks good, but I wanted to know the implementation of this thing then. It's not derived from anything. Just there's a type diff, type diffs, whatever this is. In this case anyway. Type diff. So using type is something that, yeah, this is not undefined, I don't know. Let's make it a void. Then I need to specialize it for everything that actually has a constant factor. Like, well, no, we're just talking about. Well, let's do it like the default is 1. That makes sense, I guess. Isn't that kind of weird actually that I'm using a type here instead of just a constant value? No, whatever. So the constant factor is always 1, except when it isn't, and it is only not when it is a product. And a product is a template from product something. You see products. Product uses just 2 expressions. But really, I'm only interested in when the first expression is constant. So let me replace this one with the stuff that constant takes, which is just an int enumerator 1 denominator 1. That time. You want so now the type of get constant factor, which is a struct, is always 1. But I added a specialization for the struct, namely here. And it's considered a specialization because I add here, template parameters, which are more specialized than the 3 parameters that we have here, which is none, just E. In this case, it's a product. I mean, you can only, E here is, well, it must be an expression, but that includes products and other stuff. And this one says, no, it must absolutely be a product. So therefore, it's a specialization. And then fill in, and you need a few things that I don't know, so those are just listed here. And if this this type, then the type will be set to that constant. And well, the product is constant times any other expression. So this extracts the constant part of a product. So this then returns either 1 or it returns the constant factor of a product if E1 and or E2 are products. And then I still need to implement this one, which gets the other part of it. But is a const reference, so this must be a function. You can't specialize functions, however. You can overload them though. So let's say we start with the most general one, so template expression, some expression, auto. So now we did just define a function which takes an e const reference argument, and I want to call it argument 1. I don't know why. There's only one argument. Okay, I'll call it argument. So in the most general case where there is no constant factor, okay, we return 1 because there is no constant factor actually. It's just the argument itself. But that would not be correct if argument contains a constant factor, aka if this is true for that thing, aka if it is a product. So we have to overload this function now for that. So we get something like that type, products, yeah, including that. Which clearly has template parameters 1, 2, 3. So that's just the same list as here. And the compiler should be smart enough that if the type fits this, that it chooses this one instead of the more general one. God knows why it's not called specialization. Nah, maybe it won't even work. Actually, I think it doesn't work, yeah. It's not a specialization, therefore its specializations are like if it fits and it is very special, like, oh, no, that's a coincidence. The thing that I tried to pass is a product which starts with a constant. Wow, now let's pick this one because it matches so nicely. But if you do functions, which you cannot specialize, but you can overload them, it's going to say, okay, I have a product of a constant with something that fits, this one fits. But this one fits too, because that can be anything. And it's going to say, that's ambiguous, there are two possibilities. And if I run into that, I'll just have to tell this one that it's not allowed to accept that type. But I'm going to wait until I run into it. Anyway, so arg is a product, and I want to get the e2, which is just argument 2 then of that product. Now we have something that we can try to compile. Expecting errors. Oh, it's a static assertion. So one of the static assertions failed to the requirement is same. Oh, it's just a constant reference problem. I thought I would compare two things and both would be constant references, if you heard me talk about that. But it isn't, so this one has a constant reference, that one doesn't, and therefore they are not equal. But yeah, of course I consider these equal because both are just simple 5, whatever. So this is not good, and that's on which line? This line. The first one was a constant reference, yeah, but the second one wasn't. Why is this not a constant reference then? Get non-constant factor. I think I just forgot to add a return constant reference. Yeah, no, they are constant references. Yeah, I had planned to return a constant reference, but so again for the 100th time, auto is never a reference. It's like yeah, it's just not a reference. So it's always by copy if you just return an auto. Wow, it compiles. Symbolic test suite. That worked except for a single test, and that test still doesn't work. So I have a plus 2a, that should be 3a, and well, because this has a constant factor of 1, this one has a constant factor of 2, that would be added, getting 3. The remaining types of the non-constant factor is a, the non-constant factor is a, that is the same. And then it would say, okay, I return 3a. Clearly it has not done that. And now the task is to find out why on earth it didn't do that. I think this plus here should get us there. Let's do this in small steps. Oh, maybe to fix me as a hint. No, I think we get here. Okay, let's say I want to know if I get here, but this whole thing is compile time, so that's, you can't run in a debugger or something. That's not a real function. But I can add a static assert, and then if during compile time we break, then false, let's say false, we get here. But I only wanted to instantiate, well, this would work. Well, if it is, no, actually, during parsing, this is already failing. I want to know when and from where this function is being called, between quotes. So I want to know who's instantiating it. So it must only be triggered when it is instantiated, and therefore we use call the dependent false. Yeah, it gets a color. And then any template parameter, I don't care. Value, I think. The dependent false is nothing special, it's just something derived from false type. But at least now it depends between fat quotes or on some template parameter. So the compiler is like, I don't know what this is because I don't know what E1 is. But if now this thing is being instantiated, aka it knows you try to call the operator plus with some arguments, so it knows what E1 and E2 is, and then it's going to fail because it is always false. And now we know where it was instantiated from, right? So now I could run it, but then it's going to be instantiated like super early, aka there, the very first plus in my test suite. And I don't want that to be triggering it. I want my actual failing test case to be triggering it. Down, down, down. No, not there. Now I have to find the test case. Because it did not give me the line number. Well, previously. Ah, there it is. That one. So, no, that one. That one is the one. So we'll leave this one in. It's gonna assert now on this plus, which nonsense because that works anyway. So let's begin with just removing every test that completely. Yeah, they did none of the beginning tests actually. It contains an addition. I think this is main or something. Yeah. But okay, if 0. Now it's just the very first test. So if now it fails, it's failing on my test. Yeah, the one that fails. Oops. Yeah, because it's the first test. But not on the static assert because, oops, I commented out the declaration of a lot of things that I need. At the very least 2 and A. is used here, dude. What the fuck? Here it is. So we need those. And I need A. Guess I have, that is VWXYZ. A is here, so I could do, well, there is no addition in front of this, it's just to do, yeah, well, blah, blah. Well, I'm gonna do this. Main, just remove this down to where the first addition occurs. The first non-constant addition, that is. That's a string. That's an addition. Hopefully that works. Yep. So now it says we get here and we get there from this plus. Yeah, that's the test that I want to test. Very useless, but hey, now we can move this to assertion. So that test obviously gets here because, well, it tries to use operator plus. Now, is the first argument a sum? No, it's A, and this is the product 2 times A. So this holds, and we get here. Let's just test it anyway. So, yep, you still get there. Because this is not a sum, and this is also not a sum. Now, is E1 less than E2? I shouldn't be, because this less than should compare. Actually, maybe it is. I think it is. That would be wrong. Yes, I'll be lazy and see if we get there. Yeah, so that's the reason. What we really want is that it's not less than, because one of them is A and the other one is a constant times A, and I want to ignore the constant. So I have to look at the definitions of if is less, or maybe even move it. What am I doing? Okay, well, grab sources is less. I define that in expression and then specialize it in for everything, but it's more like only to be used for addition. So I think I'm going to remove it everywhere and put it in only in sum. Let's just redo it. So let's begin with just completely deleting everything. Maybe not completely. Let's start with saving this. Delete. No, vi sum.h. So I'm going to need the is less in this operator, so I might as well put all the stuff here. And if I do this, it's always false, which is probably not what we want, but it's a good beginning. And then I'm just going to, okay, maybe I'll just move everything one by one. Yeah, I think this is still correct. Two constants with different values basically are not less than each other. I mean, 1 is not less than 3. Just a constant is a constant, and it's only less than a symbol or a power or a product or anything like that. I'm not sure what this is, yeah. Or less than a non-constant, yeah. So E2 is not allowed to be a constant. Two constants would use this still and be false then. Yeah, we need an ordering here such that a sum is ordered good enough to bring things that can be combined when you add them in next to each other. If you get what I mean. So during addition, you can get, say, if I have a plus b plus a, then I don't see that that there are two a's. I just don't see that. So I order these alphabetically, basically, and now the a's are next to each other, and that then allows us to make it 2 times a. So for the case of symbols, we definitely want them to be ordered by the ID of the symbol. Yeah, so this would be correct. Now, if you want to, this is not really required, if you ask me. This would put all symbols on the left, but if, yeah. Oh yeah, no, of course. Yeah, they have to be. Yeah, I mean, if without this, you could still get something like I don't know. So the constants must be all the way to the left, and then all symbols, and then other stuff like a to the power 2. So powers, and then we have also products. So in order, if B is actually an A, so they must be next to each other. So if the B is over here, it must be moved to the left. So B is less than anything that is not a symbol, and less than symbols that have a larger ID. So it must be always true if we are comparing a symbol with anything else. Except when that other thing is a constant, because it must be on the right of the constant. Yeah, so it must E2 cannot be a constant, because then we want to be on the other side. And it can also not be a symbol, because then it depends on if it is A or B, the order, which is determined here. So I think this is correct. Yeah. I think we'll only get problems for the product. So the power is also still probably already correct, and I can just move it. Is less. So this compares two powers with each other. And this compares a power with a non-power, and a non-symbol, and a non-constant. So it's kind of the same things we did here. Just symbols, ordering of symbols among each other, and then putting them in between the other stuff. So the constants on one end and the rest on the other. And here we have constant symbols on the one end and the rest on the other side. So this is kind of trivial. Cannot be a constant symbol or a power, which we're going to do here. And then it's a true type. But this is incorrect, because that would mean that E2 can be a product. So this is incorrect. Because a product could be a constant times something. And that something is actually what we want to compare with then. But okay, ignoring constants and products, the way to order powers are, well, it doesn't really matter, I guess. As long as they're different, right? No, they must have an ordering. They must have an ordering in order to get the same types next to each other. And that depends on both the symbol that is being exponentiated, but also the exponent. So we derive the thing from true type only if the symbol, the base symbol of the exponent E1 is less than E2, or the exponent is less. What the hell, man? That is nonsense. When you get a correct ordering, you have to order on one thing, and then only when they are equal, order on something else. So I think we order on this one first, on the symbol. And then when the symbol is equal, we can order on the exponent. Which means you can only order on the exponent if the symbol is equal. And it is equal when it is not the other way around, less than. So if the symbol is less than, it's less than, and if the symbol is E1 is not less than E2, and E2 is not less than E1, then they are equal, and then we look at the exponent. Then it's less than if the exponent is less than. And in this case, yeah. Chemical chimps, what did you try to do then that failed? You have to be on Linux, right? Was it just you didn't get it to compile or what? I think I need a specialization for E2 being a product or not. So this one is only correct for one that is not a product. Although it would be okay to be a product if it is a product of a constant times something, and that something is then less than according to, but that would be recursive. Wait a minute. Yeah, not easy. I don't think the recursiveness is going to work. So let's add another one then, especially for when there is a product. It's not only a product, it must be a product of a constant with something. So it is a product and the first argument is a constant. But even that is not enough yet. Plus that is not a specialization. Damn it. Again, I mean the requires seems to make it a specialization, but I'm trying to make a specialization. Otherwise it would be just, hey, you're trying to define struct twice with the same name. The compiler must see it as a specialization in the sense of C++, and it won't if it just requires is different. You really have to make it the type itself here more specialized than the one here. So in this case I want E2 to be a product, so I'll just have to type it out here as a product. Otherwise it won't work. So that's going to be a product of E2 with E3 then. So now it's specialization because this thing is more specialized than that. Ignoring the requires. And then I can use the requires to make sure that it is less than is in the way I want to, which means that now is product E2 is now nonsense. It is a product and it's not E2 anymore. So I want E2 to be a constant now. Yeah, and of course, since I forced it to be a product here, it's not a constant. or a symbol or a power. Still feels a bit recursive here. So it will be only less if this is less than E3. If less V. Now, E3 cannot be a product that starts with a constant, so it's not recursive, because this is a product, E2 is a constant, so therefore this is not going to be a product that starts with a constant. If it was, then the constant was already combined. So this is going to be, yeah, well, not this. So this is less V, will not use this is less because of the requires, because of this requires at the very least. So I have good hope that it won't blow up because of recursiveness. Yeah, I'm kind of lost track on what else we have to do. Let's just write. Undeclared identifier less V. Interesting. Oh yeah, this is in product. Now I know what I was doing. Moving stuff. So I was doing a grab source on is less. Everything is moved to some except product one. So let's do that one. And then if I fix that as well, and everything should work. Is less is less. Uh-oh, reverse is using is less. No. Why would it do that? Oh, there must be product is less, I think, also. Yeah, of course. So I'm not using it anymore. We just added these on with products. So this is comparing two products, and here I'm doing what? Everything else, I guess. Well, any product is less than stuff that I didn't even define yet. If E3 is not a product, and nor power, nor a symbol, nor a constant, I don't know what it is then. Oh, an addition maybe, yeah. A sum. Product is always less than fancy stuff. Yeah, well, we need ordering, so, and then comparing two products. The problem with any product, including this one, now I think about it, is that it might be a product that starts with a constant, and I have to get out the constant. So this is also, again, not good. Let's begin with this one. Yeah, you can't do this. This only works when E1 and E3 are not constants. I'm again needing the get the non-constant factor, which we just wrote. So maybe I can use that. That was called get non-constant factor, which doesn't get a core because, oh fuck, wait a minute. Right, next, right, quit, make C tags, VI. See, though, this one is overloaded for a product that starts with the constant. And then we just get the second argument. Or we get the argument itself, if that is not the case. Which is perfect. So I need to call get non-constant factor. But it doesn't return me a type. Yeah, really I need to replace this E1 here, I think, with a non-constant factor of the whole product. Which is then either the product itself or E2. But I'm using E1 here. Okay, now I see. It's comparing the first factor, even if it is, as long as it's not a constant. But if it is a constant, then it would be not less if E3 is also a constant. No. Can't wrap my head around it. Let's just delete it and start over-ish. So, comparing two products. Man, it's going to be a monster equation. There are four possibilities, I think. Let's just split them out. Like, we have not a constant for both of them, E1 and E3. Or, well, I don't know, not a constant, and then is a constant. Or E1 is a constant, and the E3 is not a constant. Or both are a constant. If both are a constant, which is actually the easiest maybe. No, non-constants are the easiest. If neither is a constant, well, E2 and E4 are also not constant. They cannot be constants because they are part of the product. So I can here do is less V E1 comma E3, or, so I need parentheses around this as well. That totally is recursive. E2 and E4 could be products. Now we get here again. Okay, let's see. Let's try it. Now, if E3 is a constant, and I don't want to use E3, but I want to use E4. Ignore the constant factor. So you get the same thing here. Except that now E3 must be E4. That's nonsense. Oh no, it's not nonsense. But I'm comparing E4 now with E1. So E4 is equal to E1. What to do with E2 then? I guess that would be false then. So this is not less than factor that doesn't exist. So this would be false. So this is false, or this whole thing can be deleted. Expect the same thing here. Now E2, E1, sorry, is a constant, so I want to compare E2 with E3. And then we can go no further. So E4 is not used again then. Yeah, well, whatever. Just okay. Definitely need a good test suit here. Now, if both are a constant, then it's going to be is less V E2, comma E4. Right, should be it. Oh, this is a test. Excuse me. So I'm testing that some power is always less than some low product type. Well, that's not true. In this case, we have the power of symbol 2 is, well, symbol 2 to the power 2 is not less than the product of a constant, which must be ignored, and a symbol 3. So actually, this is like saying the power is less than symbol 3. That's not true. Powers are not always less. And the problem is the low product, I think, because the low product is defined as a constant, and that is ignored. So really it's equal to the some symbol type here. So the constant type is less than the product, because it doesn't matter if the product has a constant factor in it. Then I would have to compare it with the second term of the product, which is not a constant. So this is correct. This should be equal to the less of constant and a symbol, which is indeed less. And the other, if you swap them, then of course it also should change the truth value. But here I'm comparing some symbol type with some low product. That is actually comparing two symbols. This is less is, what? Check that again. Some symbol type is Y. There's also some symbol type. I would say that's wrong then. It's not less if you compare two symbols. What's that we did? But it is still not, even though they're swapped, because you're essentially comparing the same type. So the same comment here. And that's because some power type has a lower symbol, I think. Or higher symbol. Huh? No, it's a lower symbol. But it's power. So really the power is larger than the symbol in this case. Exactly the same comment then. This then compares two products. Yeah, it's comparing this symbol with the first one of the high product type. But it's a power, so that would still hold. The whole test thing is a bit fake here. And now Yeah, that one is failing. So, but why? I would say it is not less. Then I have to debug this one, which means that I want to comment out everything before it. Everything before it. Well, everything that uses is less, which means again all additions and all other tests like that. And of course I didn't. Oh, this is the one, yeah, because I recognized the test. Thank God. So if you now add an assert in is less, static assert, then I should see a trigger when this test is done. Can you trigger with a static assert on doing a test inside a static assert? So I hope so. So this is less v of some symbol type with a product. Oh, that's... It can't be a product then, E2. Compare a symbol with something, not a constant or a symbol. But a product is so special, I can't compare it with it. So it can also not be a product. I'm looking for... I've got it again. Jesus. Products, exactly. Symbol times products. Symbols less than products. This is a constant, this is a symbol and a symbol, this is a symbol and anything else, but not a product. It just changed it. This is a power and a power, yeah. This is a power and anything else that is also not a product. And this is also a power, and this is two products. So we're completely missing the symbol product now. Which means that it's using this one, I think. I'll have to specialize. There is less for a symbol and a product, I think. Yep, just like we did for the power. So this one also has a button. It cannot be a product. And then I added a specialization for when it is a product. So here we're having a symbol and two expressions for the products. And then struct still the symbol, and then the product. And then we need to require such that this thing is actually less, which depends on whether or not E2 is a constant. Might as well specialize it for... No, because I completely killed the product here. Yeah, can't do that. Okay, so if E2 is not a constant, then it is indeed less. So you can start with that, is not constant, V E2. Or, and when it is constant, then we just have to compare the symbol with E3. Which then we'll use this one. Well, I don't know which one we'll use, but something. Undeclared identifier some symbol type. Interesting. I commented something out that I should not have commented out. It didn't work anyway. Going to put it back here. Yeah. Still not working then, I guess. Oh, well, we did pass a few, I think. So only 3 left, so. I think I fixed this one. Or not. Something was fixed. So which is this one? Oh, product up front. Ah, right. Yeah, no, totally makes sense. Yep. That's probably the last one that is missing. If the first one is a product that starts with a constant, then it also does not hold that it's always false. Need a specialization for that one as well. Yeah. Product and then something else than a product. This is purely for 2 products. This one is for product and something else. But not what I was testing. Product. Product constant. Less than. That's all these false. Product symbol. Yeah, product symbol could be. So I think that for everything that is comparing with the products, I also need to swap the arguments, implement that one. So this is symbol products, and now we also need a product symbol. Let's say swap these two. And then I'll just renumber them. 1 and 2 and 3. Really? Why? Int ID 3, but doing it anyway. So the product is only going to be less than the symbol, and E1 is a constant. And then if E2 is less than the symbol. And then we have power something else, not product or powers or anything. And then here I have a power and a product, so you have to solve these two. Put the product up front. Yeah, that's the one that was missing for the last test case. But let's renumber stuff. So I want my expressions up front here. These two. I'll search for that. Just type that again. Or I could use it. No, I don't know. I'll search for it again. I'm gonna use S for symbol types. I don't know. It's not an expression. I want symbol types to be S. But yeah, then this one, you know, that belongs to what? It's not 1 and 2 anymore. I could start at 3, but then I might as well call this one 3. I think, oh yeah, all of these are actually part of argument 2. Maybe we should call this expression 1a and expression 1b. That would make more sense. And then I can call these 2, 2, 2 because they are part of argument 2. It's a mess, in other words. Or I can just number. I'm just gonna call it S, really. Then I don't know. I just have only one of those either. I don't know what I want. Anyways, when is this less? Well, product is never less than a power. Unless, of course, U1 is a constant. Hello, deep apps. Why you open the live in work? Interesting. Which translation application did you use there? I don't understand it. It's not a good translation. If constant VE1 blah 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 is less V power, what am I talking about? Must be a constant, and then E2 must be less than the power. Gotta be kidding me. What? No product is suddenly less than some symbol type. Yeah, no. Okay, I just added this one. Product times symbol. Well, that's impossible. That is impossible. I think that one way to test if I get here is I think I can just put a static assert in here. Huh? Yeah. Let's do a static assert. The dependent false of whatever. Yeah, really, it's so annoying. Not curl, that one. And again, undeclared identifies unlock product type. Okay, we get here at the moment that we're doing is less. Here. just pause this. It suddenly compiles. Huh? What the heck? Okay, now got here. This one triggers it. So at least now we know that it is using the right is less. I really don't like these compile errors. It doesn't even say what these types are. Oh, maybe here. Differentiation off, okay. So a product of a constant with a symbol and another symbol, and then ignoring the constant, I would be comparing symbol with symbol, which should not be less, of course. And therefore the is less should return false. But it fails while I'm having a not here in front of it. Now I'm puzzled. I think the fact that we get here already probably means that the requirement was correct. So this did hold. Can at least test that. Of course it should hold, right? So, you know, the static assert fails, but we get here is not triggered anymore. It means that this is instantiated with the requires holding, and then of course it should be true. But I really expect a false. So why the hell is this being instantiated? Oh, because I'm having an OR. Oh, I'm such an idiot. Yeah, E1 must be a constant and the last must be true. Duh. Problem solved. Now let's do a normal stuff again. I think I commented out this from the top here. And this probably comes from here. Could be. So I don't have one at the top of main. Nope. I have too many if zeros here. static assertion field due requirement is less product constant 3 symbol 2 product symbol 2 power symbol 3. Well, first of all, a product of a constant times something should be compared as what the something is, so the symbol 2. And here we have a product that does not begin with a constant, so we are comparing a symbol with a product. The symbol should be compared less. So yeah, I agree with that, I think. Oh, okay, I see. That's funny. Yeah. I had this feeling that something was missing, but now I see what it is. So what I have done is compare the symbol 2 with the symbol 2. And then was like, what about this one? That's stupid. I should have assumed the complete product. Okay, so sim.h. Okay, here we're talking about product times product, which is not exactly what I've been working on the last half an hour. Product. Yeah, no, that was that part where I said, you know, I'm not using E4 and stuff. Let's redo this. Okay, so if E1 and E3 are not constants, then we just compare E1 with E3, and if they are equal, we compare E2 with E4. That's totally correct. Cannot be wrong. If, however, E1 is not a constant, but E3 is a constant, try that again. E1 is not a constant, but E3 is a constant. Then I have to compare the whole product, not just E1. That's wrong. But if they are both constant, then we compare E2 and E4. Yeah, hopefully that doesn't blow up. That was product with product. This is a product of a constant and a power times, again, a product. Damn it. So it's not working. What did I do wrong? Product of constant and power less than product without a constant. So E1 is a constant and E3 is not. That would be this one. That returns whatever this returns, comparing E2 with the complete product. Where E2 now is, which type? the power. So it's a power with a constant, should be. No. Power of the product. That's this one. Should be false. So this is false. This is false. Then the whole thing is false, right? So it is really false. Let me get some non-vocal music. It is false. That's why it fails. But it should be true. It should be true. I keep forgetting this. Make a copy of it. There's a product and a product, so you get here, and then the E1 is a constant, and E3 is not constant. Therefore, this is the one that we're going to do, and I'll equal less on E2, and the product will be E3, E4. Where E3, E4 or is this thing? Wait a minute. This thing, yeah. Product of a symbol and a power. And E2 is the power. It should be true. So that then is wrong. Power and product, where there's no symbol inside. Sorry, no constant inside. Power of... no. Yeah. Power is less than a product. Here's the power product. That should return true because yeah, it is wrong. It is wrong. The point is, power is always less than a product, unless E2 is a constant, and it is not. So this requires that either it is not a constant, or no, I think this is the thing. Everything works. We have the 3 times A. No, next. For A. And just A and 0. Alright, all the tests work. Well, might be that addition is now working, but I do not have a very exhausting addition test, I'm afraid. You could test this one, for example. This one leads to 0. Yeah, it's about sorting. So this is a product, but the first one is a constant. So it compares like A, and therefore the A should be shifted. So if we do this one, but then make it a B, and then see if I can shift it somewhere in the middle of a bunch of variables. So let's say I'm doing A plus B plus C plus D plus E, whatever. I have that E also, I don't know. And then plus minus 1 times C. So this should be, this stays a product, but it should be shifted because C is less than E. And so on until it meets that one, and then will be evaporated. So we have E plus B plus D plus E as answer. And unfortunately, I'm getting minus 2 times C. What the hell? So that definitely did not work. Why? The shifting works, but we didn't get a 0 there. But it does work in this case. That's really weird. Strip of the A. Still failing. Still minus 2C. Strip of the B. Now it's plus 2 times C. That is pretty arbitrary. But okay, let's let it be wrong. Straight of the E. Two times C plus D. Yeah. Now a strip of the D as well, and we get the exact same thing as here, so that should work. Test it anyway. So I remove the D. Yeah, no, it's 0. What about if I put it on the other side? Plus C. Still minus 2 times C. Yeah, still going wrong. Oh no, maybe now I can strip off the D. Nope, now it's 0 again. So the D is required. What do I add the D on the other side? Now it's 0 plus D. Well, that's an interesting one as well. Yep, that would do it. So now you catch it during compile time, which is a lot better. See also where it happens. Hmm. Did I never tested it? It's amazing. Duplications, yeah, it's kind of addition, right? Okay, so that's why I never tested it. Okay, now this one. Where does that come from? This becomes a D plus. Actually, the ordering is, I think, going to be moving this, swapping this around. Yeah, it's going to swap this and then swap that one also to that side. I want to get as close as possible to the last operation, obviously. So I think that this one is kind of obvious. But we can just test what that becomes. That would be the first operation, right? Just print it. Yeah, no, let's not print it. Let's do tests. So that part, that should become, I think, minus C plus D, right? Yep. Therefore, I might as well start with that here. I think I can repeat this then with minus C plus D. And then plus C. Yes. But yeah, that is a sum plus a non-sum. Argument 1 is a sum. If not is a sum, argument 1, it is a sum. If not is a, it is a sum. If not is a sum E2, that's correct. So we get here. I think the fix me there is looking at me. It's waving, it's blinking, it's red and white. Yep, that's the reason. We found the reason. No, it works. Okay, anyone has a challenge for me? Type in a formula in the chat, please. You can use multiplication, division, and addition. I don't think you can subtraction. Can you use subtraction? Oh boy, we don't have subtraction yet. Or do I? Not even sure. I think I'll challenge myself, but feel free to type in it in the chat something if you want me to test. Can I do a minus b or can I not do that? Cannot do. I cannot do minus yet. Well, actually, we can do minus here for two constants, but that's about it. Negation and adding or subtracting constants can be done. But that can't be too hard to add because I was going to just mimic the minus r as with addition. With the help of that, well, I can just add it to sum, I think. So it's kind of the same as this. Well, it worked, except that it's sum of a symbol plus the product of -1 times the symbol. Yeah, probably should be printed a little different. Just a printing issue, right? This. No. Because it's the sum of a product as such with constant -1. Pretty much a gist of it, I think. Printing sums. Let's just change printing sums. Printing the second parameter is a minus sign. That does change something. I'm not sure. I don't know. Okay, this is the same, right? So the parenthesis here might change. It is a minus, so I have to figure that out first. the precedence would change. No, I can't do this. Let's just oops, make a complete different branch here. So that would be the plus thing, and then when is it the minus thing? Well, it is a minus thing when we are trying to add something that is multiplied with a negative constant. So it must be a product. Product. What must be a product? Argument 2. Which is that type. Yes, and that's not enough. The first argument must be a constant. Can't do that though. You have to start all over again already here. That's pretty nasty. I think this always compiles. I'm just going to remove the else. Then I don't have to repeat that block. So if it is a product, and only when it is a product, you can look at the archetype, arg1 type, and if it is a constant, and only if it is a constant, I can do a constant expression if looking at. You gotta wonder why am I doing constant expression stuff here. Well, yeah, because I can only do these things. You can only look at argument 1 type if it is a product. So if it is a constant, I can actually call I don't have an is negative, do I? Is negative. Oh no. I have an is 0. Is -1. Do not have a negative. Oh, it's less than 0. Duh. Duh. Yep, okay, so if E2, which is a constant, is less than 0, then finally something return, because something here. Because in all other cases we can just fall through and print plus, etc. And now what I'm going to do here is print a minus. Oh, wait a minute. Yeah, well, yeah, yes, I do. Print a minus and then print. Yeah, then I need to do the need parenthesis thingy. Parenthesis. I don't know, something again. And if that is the case, we print a parenthesis. And we close them as well. And then here I want to print a negative of argument 2. I'm just creating a new object. Auto term minus arg2. Can be a temporary, why not? Now the need parents, yeah. I need a minus arg2 of that as well though, so let's make it auto term is a minus arg2, and then I do this term here. And then we can do term dot precedence. My own precedence has changed into it was sum. It's no longer sum, it is now after subtraction, which of course I have support for, right? Right? Difference? No? Uh-oh. Okay, let's jump to sum, see what we have. Difference. That's what it is. Diff is division. Unbelievable. Okay, that should work. If it compiles, it works in this case. It does not compile. Is less than 0 in product. Dude, it's not a product. This must be argument 1. Argument 1 is the constant. X minus y. Why is that not good? Oh, because it has improved. Yeah, definitely. So it does work. This is now changed into printing x minus y. See if we can find another one. So plus something like that. Not found. Okay. Dang, it works. Now I can do a minus b, and absolutely nobody in the chat gave me a challenge. It is very disappointing. I'm going to assume that you all have turned off the sound. Yeah, sorry. If anyone has sound on, give me a challenge. Addition, multiplication, division, exponentiation. Challenge is you give me a formula and I put it in, and then we get a simplification out of it. Everyone is either a bot or they have sound off, I think. Or they can't type. My excuses for those who cannot type. They're just watching. it seems that I have to make it up. Make up something. Oops, that must be a constant. My bad. Can't use ints. Too many of these, to my taste, but okay. Guess I'll keep doing it. Const expression is constant v e1. Was it e1? Okay, so. Run that, please. Thank you. We're getting this. Is that a better then or something? Maybe this better. Oh no, it's not better. Yeah. It's still printing plus minus C. Why? The rest is good. I wanted this to be printed as b minus c, obviously. That's strange, isn't it? Probably, it's of course being a sum, right? This is b plus a sum. And the sum then starts with minus c. So it's, yeah, oops. Not a product, it's a sum. Oh, right, that's the reason. Can make an exception for another sum. Of course, I can make an exception for another sum. I'll kind of have to do that. So I have to edit sum.h again. Yeah, and then look for the print. And then make an exception for where this is a sum instead of a product. Starting to be ridiculous again. Because if it is a sum, then I have to do the exact same thing again, but then for the first argument of the sum. Which is, by the way, definitely not a sum. Hey, Gustavo. Well, I just asked the chat to give me a challenge for some expression. Maybe you can make one up. So nobody else is replying. Well, I have addition, subtraction, I hope, multiplication, division, and exponentiation. But I have division is just the same as multiplication, really. So if you start to use that one with all kinds of complex things, then I'm not sure if much is happening. Probably should restrict yourself to addition, multiplication, and exponentiation. Or they can throw in a few minuses here and there. Okay, so if this is a sum, then I want to do the exact same thing as above, but then for the first argument of the sum. Meaning, it's exactly the same thing, man. I don't like this at all. Probably should define some kind of template function again. An inline, whatever. Where did I get that from? Yeah, the very top. Yeah, Kotaro, are you still there? Is my mic off? Testing. No, my mic is on. That is true. I can't multiply with the sum yet, actually. Can't do that. Product sum.